I've completely stopped worrying about crafting the perfect system prompt. Honestly, it's become pointless. The old prompt engineering tricks just don't matter anymore. When I started building with agents, I did not get better results by giving the model more access. I got better results by doing the opposite. I made the callable surface smaller, gave each action a clear schema, separated context from rights, and forced the dangerous operations to pass through a deliberate approval step. The pattern was simple: let the AI app discover what it can do, let the integration describe inputs and outputs, and keep the user in the loop. I did not need a new backend for that. I needed a clean boundary for the AI caller. That boundary is what MCP, the Model Context Protocol, is trying to standardize. This is the part that clears up most of the confusion. MCP is not your API layer, it is an agent-facing protocol that often sits on top of APIs. Your product still needs normal contracts, normal auth, and normal business logic. What changes is that an AI caller may not know in advance which operation it needs. A normal API assumes the caller already knows the operation. With an agent, the caller may need to discover what is possible before it acts. MCP splits the system into three rules. The host is the AI app, the place where the model and user interaction live. The client is the connector the host manages for one MCP server. The server exposes capabilities. The word server is misleading here. An MCP server can be a remote service, but it can also be a local subprocess launched by the client. That local version can read files, run commands, or call install tools depending on what it exposes. Local does not automatically mean harmless. It can be closer to the user's machine than a web API ever gets. MCP currently standardizes two main ways to talk. STDIO is for local processes with JSON-RPC messages. Streamable HTTP is for HTTP endpoints with optional server-side events and session handling. That answers how the messages move. It does not answer what should be exposed through those messages. The easy mistake is to wrap every endpoint and call it done. That gives the model a menu of low-level operations, including operations that were never designed for natural language selection. If the server exposes delete, export, deploy, refund, and admin update as equal options, the protocol is not the problem. The surface area is. A tool should be a test surface. It needs a clear name, a description the model can use, a JSON schema for arguments, and ideally structured output the host can inspect. The best tools are specific enough to be safe and useful. But the schema only shapes the call, it does not prove the call should happen. I would not trust a tool because its description says it is safe. Descriptions help the model choose, but they are still text. Security has to live in validation, access control, approval, logging, and the downstream system. If the only thing stopping a bad action is a sentence in a prompt, I do not consider that a boundary. MCP separates actions from context. Resources are the variable side, documents, files, schemas, logs, records, or any data the server exposes through URIs. It also means a read-only integration can still leak private data if the resource boundary is careless. Read-only sounds safe until the resource is a customer record, a private repo file, a production log, or a schema that exposes more than the user intended. If I give an agent context, I still need to decide which context belongs in the session. A resource boundary is not optional just because no write happened. MCP servers can also expose prompts, which are reusable templates for common workflows that can be useful when a tool needs a specific style of reasoning or a repeatable test shape. The problem is that prompts can quietly become where people put policy. I do not want policy hidden in text, the model might fall inconsistently. Before any of those pieces are used, the session initializes. The client sends the protocol version it supports, its capabilities, and client info. The server answers with its version, capabilities, and server info. For HTTP-based MCP servers, the authorization story should be real authorization, not a shared secret pasted into a config file forever. The spec points toward OAuth style protected resource metadata, authorization server metadata, and proper client identity. The detail I care about is simpler. The MCP server must know who the user is and what this client is allowed to do. A lot of MCP servers will be proxies over existing APIs. That is useful, but it creates a consent problem. If the server forwards tokens that were not meant for it, or acts on behalf of a client the user did not approve, the downstream API may see a valid token while the actual user intent is unclear. That is a real design bug, not a prompt issue. This is why I do not think MCP replaces APIs. The API still owns the business contract. MCP exposes an agent-facing subset of that world. If the underlying API is vague, unsafe, or inconsistent, MCP will not clean it up automatically. The other mistake is making the MCP server a second application with its own version of the business rules that creates drift. Now the normal app, the API, and the agent surface can all behave differently. I want the MCP server to adapt, filter, and describe capabilities. I do not want it to become the real product logic unless that is the product. So do you really need MCPs? Not if your app already knows the operation, not if the integration is simpler as an SDK, webhook, or backend job. MCP is worth considering when the caller is an AI host that needs discovery, context, and controlled action. If a normal program is calling your system, just design a good API. That's it.